Hey there. Last video of the sequence here in the stoichiometry unit. So this one's going to be on calculating percent yield of a reaction. And once again, what we need is a balanced equation. Hope you're getting to like this equation since I've been using it quite a bit. And we'll mix it up here a little bit. So let's mix the units. So we're going to say that in this case we have 2.22 moles of N2, and we're going to react that with 10.0 liters of H2, and we're going to say that we are going to actually produce, let's make it be something like 4.00 grams of NH3. Okay, so let's get our bearings here, right? What we know is that this quantity right here is already in moles, so we don't have to do any conversion out of moles. We know that this is in liters, so we're going to have to use 22.4 in order to do a conversion. And we know that this ammonia is given to us in grams, so we're going to need the molar mass of ammonia, 17.04. So remember, this when we say in this kind of a problem that is actually produced, this is not the theoretical yield, but this is what we call the actual yield, right? And it's important to understand that when we talk about percent yield, that percent yield is equal to the actual yield over the theoretical yield, the whole thing times 100. So in this problem, we are actually going to be looking to calculate the theoretical yield of ammonia, and then use the theoretical yield of ammonia in this equation up here in order to calculate the percent yield. All right, here we go. Limiting reactant. So we're going to go 2.22 divided by 1. Remember that the coefficient is what we are using here in this shortcut method to figure out limiting reactant. That's obviously 2.222. And we're going to go 10 divided by 22.4, because that's in liters. We have to use the concept of 22.4 to get it into moles. And then we're going to divide by 3. That's going to give us 0.149. It's always the lower of the two answers that is the limiting reactant. So we know that the limiting reactant in this case is H2. So we're going to start the calculation to determine the theoretical yield by going 10 liters, that is liters of H2, times 1 over 22.4 liters of H2, and that's 1 mole of H2. And then we're going to multiply by the coefficient ratio. Remember that the unknown is going to be ammonia, so it's going to be times 2 moles of NH3 over 3 moles of H2. And then last but not least, we're going to convert this to grams because we were given a actual production of ammonia in grams. So we're going to multiply that by 17.04 grams of NH3 over 1 mole of NH3, right? Let's step back and look at units. Liters of H2 and liters of H2 go away. Moles of H2 and moles of H2 go away. Moles of NH3 and moles of NH3 go away. And so in the end, when we calculate this, we figure out that it is equal to 5.07 grams of NH3 is the theoretical yield. Okay, so now in order to determine the percent yield, what we have to do is we have to do a ratio of the actual yield, which is the 4 grams, right, over the theoretical yield, which is the value we just solved for right here, and then we're going to multiply that by 100. So when we do that calculation out, we get an answer of 78.9%, and that's how you do percent yield of a reaction. Okay, hope that helps.